Okay, here's a third video for 6-2 part 2. We're going down into example 6, trying to do this in a real life situation or using the formula I talked about up there earlier, S equals R theta. By the way, 18 divided by 2 is 9, not 90, so it reduces down to 2 pi over 9. Sorry about that. So if you look at example 6, talking about a satellite at 320 kilometers altitude, but remembering the radius of the Earth, this piece right here of the circle is 6,400. They talked about how whatever problem it was in the book. Then they said the try it was how far of an angle is mapped out if the satellite travels 5,000 kilometers. Again, S equals R theta is our go-to for everything arc length, as long as the angle here, they give you the angle, is in radians. This formula doesn't work if they give you the angle in degrees. Okay, so I'm trying to solve for the angle. The S is going to be the arc length, that's the distance around the circle. So in this case, that'd be 5,000. What is our radius? Well, in this case, it's not 1, it's 6,400 plus 320. That's 6,720 times theta. Well, just divide both sides by 6,720. And that's how we're going to find our angle in radians. Now, this might look a little bit strange compared to what you've seen on the unit circle, but trust me, it's true, and this is what you're going to see on a question on Pearson Realize. 0.74, let's round to the nearest hundredths. So theta is 0.74 radians, okay? Now, here is a question for you to try that looks kind of like the question in Pearson, and I gave you 2 of them. Same type of stuff you're going to see in Pearson. So there's a measure, find the measure of the central angle, the same thing I just done in the example, for the given radius and the given arc length. Try S equals R theta on both those. Alright, now these are kind of tricky. I said round to the nearest hundredth. I was trying to fool you. Ha ha ha, it's just 1.5 or 2. Alright, that's the end of that video. Just kidding. We need to answer the essential question. Now the essential question is, how can we extend the trig ratios to angles greater than 90 degrees? Well, our answer is very simply by plotting reference angles on the unit circle. Oh, by plotting, Jiminy Christmas, angles on the unit circle and identifying their reference angles. But we saw when we did the lesson and all the lectures, there's much more information in this video than just reference angles. There's memorizing the unit circle and everything else. Alright, that's the end of this video.